Okay, so in this video I want to talk to you about the intermediate value theorem. I want to try and explain it to you, and what we're going to do is we're first going to read the theorem, we're going to look at a picture, and then we're going to look at a specific example. So let's read this together. The intermediate value theorem is an existence theorem. It doesn't find a number for you or a value for you, but it does tell you whether one exists or not. So that's kind of like the big picture. Let's read it. If A is less than B and f is continuous on the open interval from A to B and f of A is not equal to f of B, then for all real numbers between f of A and f of B, let's say k, there must be at least one value of C. Now there could be more, but the intermediate value theorem says that there has to be at least one. Okay? Where C being between A and B such that f of C equals k. So we're going to try and look at a picture to make sense of this. So let's go ahead and look at that picture. Here's a function f. Here's A and here's B. Notice A is less than B. Here's f of A on the y-axis, and here's f of B. Now this curve, this function, is nice and continuous. Okay? Could be a polynomial function, but it doesn't have to be a polynomial function. And right here is a point K on the y-axis. Now because f of A is not equal to f of B, they're different values, and because the function's continuous on the open interval from A to B, then that means that there has to be some number down here on the x-axis, we'll call it C, such that f of C is equal to the value of k on the y-axis. So in other words, intermediate between A and B, there's got to be at least one point C where f of C is equal to that k value. Okay? All right, now we're going to look at a more concrete example using Geogebra. So here's the function x cubed minus x plus 1. Let me go ahead and minimize this. Oops, there we go. All right, so now here's what we want to do. I can see visually that the function does hit the x-axis here between -1 and 2. So can I verify using the intermediate value theorem, if I did not have a graph, could I verify using the intermediate value theorem that there has to be a place where this function crosses the x-axis? And the answer is yes. So let me apply the intermediate value theorem to this specific case. Now, if I plug -2 into the function, let's pull down a little bit, I'm going to get -5. So f of -2 equals -5. If I plug -1 into the function, I get 1. So the y values that we have here are -5 and 1. And 0 happens to be between -5 and 1. Now because this is a nice continuous polynomial function, the intermediate value theorem says yes, there absolutely must be some x value between -2 and 1, we'll call it C, such that f of C is equal to 0, all because 0 is between the two y values, -5 and 1. And that is the intermediate value theorem. God bless you, wherever you are today.